Hello and welcome to the module on erosion control. One of the main functions of geosynthetics, as presented in the introduction module, is erosion control. The ISO definition of surface erosion control is use of a geosynthetic material to prevent or limit soil or other particle movements at the surface of, for example, a slope. In the next slides, we will present a detailed definition of erosion control, the main problems and impacts of erosion, and how to prevent and control erosion with the use of geosynthetics. As a more detailed definition, we have erosion is a natural process caused by forces of water, wind, or other natural means. It is influenced by a number of factors such as type of soil, vegetation, landscape, and it can be accelerated by various events or activities that occur on a specific site. During the erosion process, soil particles are removed and transported, resulting in the gradual deformation and destruction of slopes, banks, shores, river banks, and beds. Uncontrolled erosion processes can cause major damages to existing structures and the environment. The main problems caused by erosion are soil loss from water flow or weathering, undesirable sedimentation on fields, roads, rivers, drainage systems. As examples, you can see in the pictures that erosion can cause landslides, foundation problems of structures, riverbank damages, etc. The main question is where all the soil and sediments go. The impacts of erosion include pollution of water courses, especially with contaminated land, reduction of capacity of the flood channels, drainage systems, increasing flooding problems, siltation of rivers affecting fish spawning areas, loss of organic soil and nutrients making it more difficult for plants to grow and increasing emissions to the atmosphere, negative effects on water quality and aquatic systems. Some facts to add to the impact of erosion are soil is currently destroyed 10 times faster than it's being created. The contribution of damaged soils to flooding events is estimated to be 233 million per year. Estimated 2.9 million tons of soil is lost every year in the UK through wind and water erosion. This is equivalent to the weight of 240,000 double-decker buses. So how can erosion, wind and rainfall erosion be prevented and controlled? The solution with vegetation. The importance of vegetation. Its foliage absorbs the destructive energy of wind and rainfall. The root system binds and retains soil particles, filtering out sediments from rainwater runoff. Increased surface slope stability, reducing landslides, creates ecological habitat, it's aesthetics and cost-effective. Geosynthetics play a crucial role to retain and establish the vegetation, providing solutions to prevent and control erosion. There are different types of geosynthetics that can be used for erosion control depending on the specific conditions and requirements of each site. For soil protection and to help to establish vegetation on shallow slopes, temporary and biodegradable erosion control mats are frequently used in these cases. You can see some examples in the pictures. For soil containment and reinforced vegetation, permanent turf reinforced mats and 3D cellular confinement geocells are used in these cases. In some cases, hard armor solutions are required, like geosynthetic cementitious composite mats, riprap, scour protection systems with rock and concrete mattresses. There is another category of geosynthetic solution for coastal protection, breakwaters, and dewatering containers. These are the geotextile tubes, geobags, or geocontainers shown in the pictures. The main benefits of using geosynthetics for erosion control are reduction of soil loss and sedimentation, protection of infrastructure, drainage systems, agricultural fields, river, coast, channels, etc. Space savings, reducing soil cover layers, solutions that require less area and volume, high resistance to weathering, cost savings, geosynthetic materials are less costly than soil materials for a given area, technical superiority, geosynthetics have been engineered for optimal performance and the solution can be designed for the specific conditions of the site, construction timing, geosynthetics can be installed quickly and under controlled conditions, and environmental sensitivity. Geosynthetics can reduce the use of natural resources and reduction of the environmental damage caused by quarrying, transportation, excavation, and disposal of material. We are going to look now at some case studies. In this project located in Ashbourne, all the slopes along the new footpath were protected with a permanent turf reinforced mat to retain the topsoil and help the development and establishment of the vegetation on the slopes. The first pictures show the installation of the mat with an anchored trench on the top and bottom of the slope and pins to retain the mat and guarantee an intimate contact between the soil and the turf reinforced mat. In this case, topsoil was installed beneath and above the erosion control mat, and the topsoil above was seeded with the specific type of vegetation selected for this project. The construction of the footpath and the installation of the erosion control mat was done in May, and the vegetation was fully established in September, as you can see in the last picture. This is a case study of a channel protection in Coventry. This is a very common scenario where the channel requires some rehabilitation works and in some cases it also requires changes in the realignment and dimensions. Once the construction works of the channel were finished, the slopes were protected with a temporary erosion control mat to retain the soil and help to establish the vegetation. You can see the installation of the biodegradable erosion control mat on the slopes and the final result. In this case study, the first pictures show the damage and destruction of the river bank due to the energy of the water. As a solution in this case, the slopes were reconstructed and protected with a high-performance turf reinforced mat. At the bottom of the slopes, a system of baskets was created with the same mat and then filled with gravel and soil. This was used for scour protection. The last picture shows all the vegetation established on the slopes and the river banks protected against erosion. This case study is for the protection of a drainage channel in Wiltshire, carrying water from an outfall pipe to a silt trap lagoon before entering a lake. What you can see in the first picture is the result of erosion over time, creating a 3-meter deep scour hole at the interface between the on-line channel and the original channel lined with concrete blocks. The solution adopted was to re-establish the channel to the original profile and then line the entire channel with a hard armor system, GCCM, due to the high velocities of the water. The pictures show the channel in full flow with velocities up to 8 meters per second. The last picture was taken 9 months after the completion of the works. For further information, you can use the links in the list below as an initial reference. International Geosynthetic Society for Technical Journals, US EPA Guidance, this is the Environmental Protection Agency, Syria, GRI specifications, among others. And finally, we invite you to join the IGS. It has a dynamic student membership. You will find information of all the regional and international conferences, access to 2 leading geotechnical journals and different conferences proceedings, and information about all the events related to geosynthetics. Thank you very much for your attention.